So officially, when we're talking about sets and subsets, we're going to define it this way. Let A be a set we say that B is a subset of A, and we write it this way. We say that B is a subset of set A, and we use this symbol. B is a subset of A. Set B is a subset of set A. If any element in B is also in A. Okay, very good. So we're going to use a Venn diagram. If you have set A, set B is going to be included in set A. Then you're going to say that B is included in A, or B is a subset of A. Okay, very good. Just note that we have another definition that we call a proper subset. Let us write this guy down here. Proper subset. When we write B, a subset of A, without any equality line, so compare these two. This guy says, hey, B is a subset of A, and there is a possibility that B and A are equal to each other. This guy say, hey, B is just a subset of A. There is no possibility that B and A are equal to each other. In this case, we say that, hey, B is a proper subset of A. We say that B is a proper subset of set A. Proper subset. Guys, learn these terminologies. These terminologies are important. A proper subset. B is a proper subset of set A if you are sure that B cannot be equal to A. There is no way that B is equal to A. But when you write it this way, it means that you do not exclude this possibility that B might be equal to A. The difference between these two. In general, we are writing B as a subset of A. So we always include the possibility that B might be a subset of A, and there is a possibility they are equal to each other. Again, in some lemmas, in some theorems, if you don't want B to be equal to A, you have to use proper subset. Example. Some example to consider. So let us work with the set S that we defined at the beginning of this lecture. Okay, very good. Which one is a subset of set S? Okay, I'm going to give you these subsets, possible subsets. A is the set including A. B is the set including AA. C is the set including A, and A. D is the set, empty set. E is the set including the empty set. Okay, so which ones are the subset of set S? Well, okay. What do we see here? It says, hey, I have set A with only one members. This member is in A and also is in S. A belongs to A and A belongs to S. It follows the definition of being a subset. It says any element in the smaller set is also in the larger set. A in the smaller set is also in the larger set. So A is going to be the subset. What about B? I have repetition here. I see A, comma A. Well, when you see repetition, what is actually happening is that this set has only one member. The repetition in set doesn't count. One element, A. The set B doesn't have two members. Set B has only one member, A. Okay, well, let me follow the definition. Any member in the smaller set is also in the larger set. So it follows the definition of being a subset. What about C? With the same logic, the repetition doesn't count. This set has only one member, A. And as you can see, A is in the smaller set and also in the larger set. So this guy is also a subset. We know that empty set is also a subset of any set. In this case, you have set S. Empty set is also a subset. What about this guy? Common mistake. Students think that this set is the same as empty set. Guys, this is not empty set. Why is that? This set has already one member in it. The cardinality of this set is 1. Just note that the cardinality of set E is 1. It has one element. Okay. So empty set belongs to E, but empty set is not a member of S. So E is not a subset. Just be careful when you are analyzing these sets, following the definition of subset to make sure you have a correct answer. So for set E, it has one member in it. The cardinality of this set is 1. The member inside set E is empty set. Empty set is in set E, but it's not in the larger set. The larger set doesn't have any member as empty set. Another example. Which one is true? So we're going to see a combination of membership and being a subset here. So let's take a look at this example, this cool example here. Which one is true? Which one is false? Okay. The very first one says 2 belongs to 1, 2, 3. The second one says the set including 2 is a subset of 1, 2, 3. C, the set including 2 belongs to the set 1, 2, 3. D, it says the set including 2 is a subset of the set including 1 and the set including 2. E, it says, well, 2 is a subset of the set including 1, 2, 3. And F, it says the set including 2 belongs to the set including 1 and the set including 2. Well, 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 what do we have here? Which one is true? Which one is false? So let's take a look at these one by one. It says, hey, 2 is a member here. Of course, 1 is a member, 2 is a member, 3 is a member. 2 belongs to this class. 2 belongs to this set. Of course, true. This guy says, hey, the set including 2 is a subset. What was the definition of subset? Any element in the smaller set is also in the larger set. This element is in the smaller set. This element is also in the larger set. So it fits the definition of subset. This guy says, hey, this element, this set, which is this element here, is a member of this larger set here. Guys, the member here is a set. None of these are sets. These are just members as numbers. 1, 2, 3. Of course, you don't see this guy here, here, or here. So this is not true. What about this guy? It says this set is a subset of this larger set. It means that if I take the element in this set, that element must be in this set, but members are in set form. Not true. What about this guy? It says, hey, 2 is a subset. When we are talking about subsets, on the left, on the right, you must have set symbol. You need to have set symbol on the left-hand side. You don't have any set symbol here. It's just a pure number. If it was the set including 2 is a subset of 1, 2, 3, you should be fine, but this is wrong. You cannot just have an object like this on the left-hand side. So this is false. What are this guy? It says, hey, this element belongs to this set. Okay, yeah, I see that just right here. This belongs to this set. So this is true. Let us add another one. Empty set belongs to this set. Empty set is a subset of this set. Which one is true? Which one is false? Both of them are true. This guy belongs to this set. Yeah, you just see it right here. This is here. I can see that. This guy says, hey, empty set is a subset of any set. This is any set. All right. Isn't that interesting? This is just any set. Empty set, we know empty set is a subset of any set. This is always true.